Stoichiometry deals with the relationships between the quantities of reactants and products in a chemical reaction. For example, consider when hydrogen and oxygen react to form water. In a balanced chemical equation, the coefficients tell us the relative number of molecules involved. 2H2 plus O2 reacts to form 2H2O. The balanced equation tells us that 2 molecules of hydrogen will react with 1 molecule of oxygen to produce 2 molecules of water. Okay, so we know that 1 mole is equal to 6.02 times 10 to the 23rd molecules. This incredibly large number is called Avogadro's number. So if we have 1 molecule of oxygen and we multiply by Avogadro's number, we have 1 mole of oxygen. And if we have 2 molecules of hydrogen and we multiply that by Avogadro's number, then we have 2 moles of hydrogen. Notice that the 1 mole of oxygen and 2 moles of hydrogen correspond to the coefficients in the balanced equation. So 2 moles of hydrogen will react with 1 mole of oxygen to produce 2 moles of water. Therefore, the coefficients in a balanced equation tell you the relative number of moles of everything involved in the reaction. We can use these mole relationships to find out how much product can be made from a given amount of reactant, or to find out how much of a reactant is needed to form a known amount of product. Reaction stoichiometry problems give us information about one substance in the reaction and ask us to find out about one or more other substances in that same reaction. There are 4 general types of stoichiometry problems. The first type of stoichiometry problem is a mole-to-mole conversion. You're given moles of something and asked to find the moles of something else. Suppose we start with 4 moles of hydrogen, and we're asked to figure out how many moles of oxygen are necessary to completely react with the hydrogen. To accomplish this, we need to use a mole ratio. Looking at the coefficients in our chemical reaction, we can see that the mole ratio is 2 to 1, hydrogen to oxygen. We put the coefficient of hydrogen in the numerator and the coefficient of oxygen in the denominator. So we get H2 over O2 equals 2 over 1. Once we have this mole ratio, we want to set up a proportion. We know that we start out with 4 moles of hydrogen, so we put this number in the numerator, and we're asked to find the number of moles of oxygen. Since this is unknown, we put an x in the denominator. So we have H2 over O2 equals 2 over 1 equals 4 over x. Our next step is to solve for x, and we can do this using cross multiplication. We multiply the 2 times the x, and then set it to equal 4 times 1. Solving for x tells us that x equals 2, so we need 2 moles of oxygen to completely react with 4 moles of hydrogen. Now, we want to know how much water our reaction will produce. To find this, we once again need to use a mole ratio. This time, however, we want to find the ratio of our reactant hydrogen to our product water. Looking at the coefficients of the balanced chemical reaction, there is a 2 to 2 mole ratio of hydrogen to water. Therefore, we put a 2 in the numerator for hydrogen, as well as a 2 in the denominator for water. So we get H2 over H2O equals 2 over 2. Now we look at the numbers we are given in our problem. We know that we start with 4 moles of hydrogen, so we put 4 moles in the numerator of our ratio. But we don't know how many moles of water are produced, so we put an x in the denominator. So we have H2 over H2O equals 2 over 2 equals 4 over x. We now have an equation, which we can solve for x using cross multiplication. X is equal to 4, so 4 moles of water are produced by our reaction. The second type of stoichiometry problem is a mole-to-gram conversion. In this type of problem, we're given moles of one substance in the reaction and asked to find grams of another substance in the reaction. Suppose we're asked to figure out how many grams of oxygen are necessary to react with 4 moles of hydrogen. We once again use the mole ratio of hydrogen to oxygen, which is 2 to 1, and set up a simple proportion. We write 4 into the numerator, and once again, we use x in the denominator to denote the number of moles of oxygen. So H2 over O2 equals 2 over 1 equals 4 over x. Solving this equation tells us that X equals 2 moles of oxygen. We now need to convert this number to grams. For this, we need the molar mass of oxygen. Because a diatomic oxygen molecule consists of two covalently bonded oxygen atoms, we find the molar mass of an oxygen atom on our periodic table, and then multiply it by 2. So 2 times 16 grams per mole equals 32 grams per mole. Next, we multiply 2 moles of oxygen by 32 grams per mole. The moles cancel, and we get 64 grams of oxygen. We can use this same approach whenever we're given moles of one substance in the reaction and we want to find grams of something else. The third type of stoichiometry problem is a grams to mole conversion. Suppose that we have a goal of producing 36 grams of water. The question is, how many moles of oxygen do we need to accomplish this? Our first step is to convert everything into moles. The molar mass of water can be calculated by looking at the periodic table, which tells us that each hydrogen atom has a molar mass of 1 gram per mole and that oxygen has a molar mass of 16 grams per mole. So the molar mass of water can be calculated as so. 2 times 1 gram per mole plus 1 times 16 grams per mole equals 18 grams per mole. Since we want to produce 36 grams of water, we divide this number by the molar mass, which tells us that we want to produce 2 moles of water. To find the number of moles of oxygen, we need to use mole ratios again, by writing down the mole ratio of oxygen to water for our chemical reaction. Looking at the balanced reaction, we find the mole ratio by putting 1, the coefficient of oxygen, in the numerator, and then putting 2, the coefficient of water, into the denominator. We then set this ratio equal to X divided by the 2 moles of water that we just calculated. So we get O2 over H2O equals 1 over 2 equals X over 2. Solving for X tells us that 1 mole of oxygen is needed for our reaction to produce 2 moles of water. Note that our final answer has 3 significant figures. The fourth type of stoichiometry problem is a grams to grams conversion. We are given grams of one substance in the reaction, and we're asked to find the grams of something else in the reaction. This time, we look at a new chemical reaction, corresponding to the reaction where potassium chlorate turns into potassium chloride and oxygen gas. Suppose we start with 4.4 grams of potassium chlorate, and we're asked to figure out how many grams of oxygen we'll produce. The first step is to convert to moles. Potassium chlorate has the chemical formula KClO3. So we look up the molar mass of each atom on our periodic table, then multiply it by its subscript in the chemical formula. 39.1 grams per mole plus 35.5 grams per mole plus 3 times 16 grams per mole equals 122.6 grams per mole. So 1 mole of potassium chlorate has a mass of 122.6 grams. We now divide 4.4 grams of potassium chlorate by the molar mass, which tells us that we have 0.0359 moles of potassium chlorate in our reaction. To figure out the number of moles of oxygen gas involved in our reaction, we need to write the balanced chemical equation. So 2KClO3 reacts to form 2KCl plus 3O2. Looking at the balanced equation, we write down the mole ratio of potassium chlorate to oxygen. We write the coefficient of potassium chlorate, 2, in the numerator, and the coefficient of oxygen, 3, in the denominator. So KClO3 over O2 equals 2 over 3. We know that we start with 0.0359 moles of potassium chlorate, so we write down a new ratio with this number in the numerator. Since we don't know how many moles of oxygen result from our reaction, we put an X in the denominator. So we get KClO3 over O2 equals 2 over 3 equals 0.0359 over X. We are now ready to solve for X using cross multiplication. We first multiply 2 times X, and we set this quantity equal to 3 times 0.0359. Solving this equation gives us X equals 0.0538 moles of oxygen produced during this reaction. Now, our last step is to convert 0.0538 moles of oxygen into the mass of oxygen. We recall from before that diatomic oxygen molecules have a molar mass of 32 grams per mole. So we multiply 0.0538 moles by 32 grams per mole, which gives us 1.72 grams of oxygen. Note that our final answer has 3 significant figures. Alright, as a quick recap. Stoichiometry problems involve the relationships between the quantities of reactants and products in a chemical reaction. The coefficients in the balanced equation tell us the relative number of moles of reactants and products. Since the balanced equation tells us the relative number of moles when we are given the mass of a reactant or product in grams, our first step should always be convert the mass into moles. Once we find moles, we can use mole ratios to determine the amount of the other substance of interest in the reaction.